3. Oh my god. That means. Dude, that's 3, 2, 2. I'm so happy.
You do math now.
Seniors, remind you again, log into close at 3:15 Wednesday, March 15. All students welcome to Forum Fridays every Friday during lunch in the Whitebird Room. This week's presenter is Nora Zor. Tomorrow during lunch in the Whitebird Room. Senior boys have received the letter to fill out the boys' state applications for this summer. It was done too late to submit that application. Make sure you get online, fill that out, get submitted, and they'll take their selection coming up shortly. Student council meeting today over lunch. Gaming room. All members need to attend the meeting. Seniors need to stop in and check the counseling office for your Regent Scholar list. Make sure you're on that. Next day's DTest is April 15th. The deadline to register is Friday, March 10th, next week. April 15th test is the next one. Prom meeting today at 2:05 in the wrestling classroom. All juniors are encouraged to attend. I believe that was yesterday. I don't think there's another prom meeting today at 2:05. We'll find that out for sure and let you know later. Don't please stand for the pledge.
Oh, I'll find out there.
Pledge allegiance to the flag
Of the United States of America, and to the republic for which it stands, one nation, under God, indivisible, with liberty and justice for all. Yes, I do.
Oh, Wolford scored.
It's about that, yeah.
It's still not yours?
Seniors will be today at 2:05.
You just took a number.
Oh, have a great day.
Yeah.
Stop trying. No one has the best water from Culver's. Really? That's why.
Yeah.
I think the best is after you finish your math problem.
I'm done.
All of it?
Yeah, wait, what do you mean? What else is there?
Okay.
Read the second part. Oh, okay. That's pretty good.
Remember, there's no point in collaborating on these because that doesn't tell you what you know. That tells you what you and your neighbor know. This is how you determine whether you understand it. While we're learning a thing, by all means, collaboration is encouraged and expected. While you're doing these, this is you. Okay? No, I suppose we should do the attendance thing, huh?
Now you need blue. No, actually, I need both. Were you listening to that song when you were here? With your brother and sister?
Also, because someone usually asks about the middle of between quizzes, 5 days then review quiz. Your next quiz will be on Monday, assuming we don't have any other interruptions.
That's a good question to ask about any of his tests. On what? Why does he tell us to do the constant forward? Yeah, but
It's fairly quick. Is anyone still going? Okay.
But that's still like seals. They look like they're okay. So like, okay, but like if you're in like a swamp, dark, that's only like you're in you see those emerging out of the swamp. That's a little scary. Well, eliminate the French.
Good. Okay. The easy part, possible real zeros, 4, possible turning points, 3, just by the leading term. After that, find all the zeros by factoring. It does say all, so not just real, but whatever kind you might find. It looks like a duck, it quacks like a duck, turns out it's platypus. This is in quadratic form, so I can treat it like a quadratic, where factors of -3 that add up to 4 are -3 and 1, but it's not a quadratic, it's a quartic. So I have to put x squared. Okay. After that point, depends what you're going to do. If you decided to take them out behind the shed and teach them a lesson, x squared minus 3 equals 0, x squared equals 3, x is plus or minus root of 3, x squared plus 1 is 0, x squared is -1, x is plus or minus I. Could have done it that way, or could have just kept factoring. X plus root of 3, x minus root of 3 by difference of squares. Remember, I can still do that even if it's not a perfect square. It's just square root of a and b plus minus conjugates. Same thing goes for sum of squares. It's just they end up imaginary. And then set all of those equal to 0. So whether you went blue or green, I don't care, but you had to have done purple to start with. Okay? So end of the road, you should have x is plus or minus root of 3, plus or minus I. We should have that there's possible real zeros, 4, possible turning points, 3. So you got the roots, you got, I'm just going to say those together. I'm going to leave factoring the first step, and then some sort of work. Like to go from a quadratic binomial to answer, you got to have something there. Okay? Now, we're going to do it enough times where once we get to purple, you might be able to just start writing the answer. The same way that when you get a linear factor right now, most of us can just write the answer. Okay? So you got the first stage of factoring, you got the second stage of whatever you felt like doing. Answer, answer, answer. Any questions about it? No? Cool. The homework, again, for those who are actually looking, I'm just posting these in the shared folder. I really should go back and actually rename them by our sections instead of just string of numbers .jpg. But 7, you should have a graph with quartic. So goes by fourth steps, vertex is at 3, 6. 9, translate it right, 9. Now it's going to be by fifths, or fifth power, but 1/3 compression to them. So 1/3, 32 thirds, 243 thirds, which is 81. And how many points did we say we want to have? Okay, 5 so you can see the curvature. So you're going to have to do a little bit of scale work on these, but that's the general idea. Okay. If we didn't do one like this where it wasn't written in general form for us, but could you multiply some stuff out and find that leading term? I hope so, because that's where we're headed in the next day or 3 is, y'all remember, here's the zeros, make the polynomial that had the zeros. You're going to have to go distribution bonkers on some stuff. Okay, so it was a negative, even polynomial. All the other stuff after it doesn't matter. That's just the leading term. So I'm going to have, as we go to plus or minus infinity, down to negative infinity, and possible zeros, possible turning points, factor and solve. For both of them, it was kind of leading into what we're doing right away at the beginning today. Sometimes you have repeated zeros. Okay, we talked a little bit about this with when we were just talking about end behavior and behavior of graphs. A repeated zero, does anyone remember what it does to the graph? Like if a zero happens once versus twice versus 3 times. It changes how it behaves. If the zero happens once, it goes through that zero like a line. If it happens twice, it'll bounce off of it like a parabola. If it happens thrice, it'll go through in a little kink right there at that zero, just like the inflection point in a cubic. So depending how many times a zero happens, and this leads directly into the first thing that we do today, do you remember writing multiplicity in Algebra 2? Okay, so the way that most textbooks want us to do it is they'll say 0 multiplicity 3, and then they'll keep listing the others. Now, mathematicians are notoriously conservationists of written effort. So we come up with symbols for stuff. There is no official symbology for this, but I think we can go cross-curricular, and we have already something that denotes a number of things. Especially for our juniors and seniors who've already been through chemistry. Second semester is when you start balancing all those equations. You're just at you're not even at the pervert law yet. Like, you got all kinds of stuff to do. PV equals nRT. It's the ideal gas constant law. It's just, okay. We use a subscript in chemistry to mean 2 of that particular element. So I usually get lazy and I just put a subscript 3 next to it to say I did 3 of them. If it saves you some writing, it saves you some writing. Okay. So that is right where we left off. State the number of possible real zero starting points and determine all the real zeros by factoring. How many possible real zeros do we got? How many possible turning points do we have? And it says to solve by factoring, go find your zeros. The very first thing that I would do is take out GCF, greatest common factor. And because I'm so used to factoring with a positive leading coefficient, while I'm at it, I'll take a negative x squared out, leaving x squared plus x minus 2. Getting negative x squared, x plus 2x minus 1. And remember that as I set those equal to 0, this guy gets me a 1, this guy gets me a negative 2. If I set negative x squared equal to 0, divide by negative 1, square root, I still get 0. And most books are going to want you to say multiplicity of 2. Oh, fine. There you go. Like that. If you want to just subscript, suppose we should close a parenthesis, right? If you just want a subscript on there, 0 happened twice. I'm cool with that. But what that's going to do for me on the graph is, this kind of leads into the next example already. I see a negative x to the even. So I know it's going to begin and end down at negative infinity. I know that it's going to hit 0, negative 2, and positive 1. And then because of how many times they happened, I know it's going to go through negative 2 like a line. It's going to bounce off of 0 like a parabola, and then go through 1 like a line. The question is always going to be, how high do those go? And the more spread apart the zeros are, usually the higher or lower it is away from the x-axis. It's relatively proportional. So because these two are further apart, I'm probably going to have something like up, bounce, down. Okay, line, parabola, line. Further apart means taller. Closer together means shorter. Okay, and this is just the behavior of the graphs. Now, you don't have to do this yet, but I'm saying it right now because we're headed into that the next thing. Okay, so picking up right where we left off yesterday, possible real zeros, possible turning points, factor, find them, and if there's multiplicity, state it. Spell who?
Lemon. Oh,
Right, what?
What?
That's an O. Well, yeah, you didn't connect it.
yeah, it looks like an E.
That doesn't make it a burner thing. He's not doing
L-E-M.
Wait. If we're going to start getting iffy about handwriting, I can bring that into effect on everyone's tests.
That's not true.
Yeah, that's what I thought, guys. Ooh. What's French silk taste like?
Deliciousness.
It's like chocolate pudding in a pie.
It's fabulous.
Did you say fabulous?
Yep.
This is you fabulous. I'm gonna be honest, I'm a rhubarb guy.
We still have some in the freezer, so. Mama Bear is taking requests. She says Pie Day approaches. So.
How do I find out how many possible turning points there are?
It's always one less than the degree.
So this is.
Yep. Always one less. Yep. Because Zeke is in my class.
Yeah.
Rachel, what is wrong with you? Oh my gosh.
I like how I can't have like half of the stuff on the board.
Oof.
Oh, the rings.
And if anyone has any specific food allergies, like I had a kid who hates birthday cake and textures and that kind of stuff, and my wife made them like just a straight up cheesecake and just figured out how to make cheesecake, having never done it before. So, like, she just enjoys making food, and my kid enjoys being at the counter while she's making food. So, yeah, if anyone has any food allergies, let me know. The cookie one is for people who just absolutely hate the texture of pie entirely. It's basically just one gigantic cookie, but it's in a pie tin. Okay. And the pumpkin pie, that is, I am also a texture eater. I can't have anything on that list besides the cookie one or pumpkin pie. Grandma figured out how to make a pumpkin pie that is the exact consistency of a brownie by mixing it together in a blender, and then you just cook it straight with no crust. So you can actually just pick it up with like a slice and just eat it. I never have had it in here with it, but we can. Yeah. So, not now. That's going to be up today, tomorrow, probably through Tuesday-ish, because then she's got to go get, got to actually go get the stuff for it. But March 14th, 314 Pi Day. Okay. So, back to actual math. First one, how many possible real zeros are there? 3. How many possible turning points? When I start factoring, I'll take out a negative 2x, leaving x squared plus 2x minus 8. Negative 2x factors into x plus 4, x minus 2. Write your zeros. 0, negative 4, 2. So they're all real. Yay. Possible real zeros. 5. Possible turning points. 4. Take out your greatest common factor. 3x cubed, leaving x squared minus 6x plus 9. In this case, 3x to the third, that's a x minus 3, the quantity squared. It's a perfect square trinomial. So my zeros are just 0 and 3. What we would do to state any possible multiplicity is say this happened thrice, this happened twice. I do that. That is not official notation. Okay? Like, it makes sense, especially for kids who are probably in chemistry. Most kids in pre-calc are in chemistry until we get to second semester. It's always first semester is junior, senior. Second semester is like 2/3 sophomores, and the other third is junior, seniors who just their schedule didn't work for first semester. So that's usually what it is. But anyway, are you cool with this? Could you write it as multiplicity 3, multiplicity 2 if you had to? This is just lazier. Okay. All right, so we're good, right? I mean, that was just one more example of what we were doing. So the examples given, it's already factored here for us. Okay, take a look at the graph. This 0 happens 3 times. Look at the behavior of it at that 0. It looked like cubic. This 0 happens 4 times. Look at the behavior at that 0. Look like quartic. Okay? So this is going to help me to start to sketch the framework of a graph, and then I'm going to use my calculator to go find the extrema and plot the actual maximums, minimums on there. How would I find the leading term of this? Think about when you had to do the longhand distribution of these in Algebra 2. This is x minus 1 times x minus 1 times x minus 1 times x plus 2. Da, 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 da. Isn't the very, very first term going to be 3 of these and 4 of these? Will it be a positive or negative? It will be a positive 1x to the 7th. So that's how you're able to just kind of shorthand it. If I know it's a positive odd, I know it starts at negative infinity, goes to positive infinity. I can also find my y-intercept because I'm going to have 3 of these and 4 of these multiplied at the end of it. So -1 by -1 by -1, -1, 2 by 2 by 2 by 2, -16 is going to be my y-intercept. Okay? What? -1 by -1 by -1. I'm saying when I distribute all of this out. I don't want to distribute it all out because it's x to the 7th. That's 8 terms wide. But when I really look at it, I'm looking for the factors because they tell me the zeros and the behavior. The leading term tells me end behavior, and the constant term tells me my y-intercept. Because if all those x's are zeros, constant term at the end tells me y-intercept. So this is just how I start to set up the framework for my graph. Repeated zeros, multiplicity, behavior, we just said that. Here we go. Okay. So, step 1. I'm going to have some leading term, a bunch of stuff in between it, and some constant term. So, let's figure out what those are so we can get our leading term for end behavior and our y-intercept. This guy, my leading term, is going to be x stuff. Literally, stuff. There's going to be things in between the leading term and the end term. and I don't want to figure them out. The first term is going to be x times 2x times a pair of x's, right? Because I'm going to have that one twice. So this is x times 2x times x times x. It's going to be 2x to the fourth. Cool? I'm just shortcutting the whole process. I don't want to multiply everything in between. I just know that I'm going to multiply all of the first terms together to get the first term. Then, stuff. The end term is going to be, this isn't a binomial. Maybe think of it like x plus 0. My constant term is going to be 0 times 3 times -1 times -1. That means my constant term is 0. It makes sense because if I take x times all this stuff, isn't my last term going to have x to the first on it? It's not going to be a constant. So that means I'll be able to take out a GCF of 0. That means that I'm going to have a 0 of 0, which is also a y-intercept of 0. All of these things are interconnected. This is what we spent half of Algebra 2 going through. So what this tells me is a positive x to the even end behavior is going to be what? Going to go from positive infinity to positive infinity. Somewhere in between there it will do things. What is my y-intercept? 0. Look at the factored form. What are my zeros? Set this equal to 0. Set this equal to 0 and solve -3/2. Set this equal to 0 and solve 1, and it happened twice. So that means at 0, -3/2, and 1, I know the behavior. I know that at 0, it's going to go through like a line. At -3/2, it'll go through like a line. At 1, it'll bounce like a parabola. This just allows me the framework of it. If you're using a pencil, I would do this very, very lightly. Is I know now that it's going to start up here somewhere. It's going to go through this, bounce off of this. What I don't know is how low do you go? I don't know where that extrema is. I don't know where this extrema is. So I'm dumping in my calculator. I'm going to go find them. Y equals. And you can put it in factored form. You don't have to distribute it out. Y equals x by, it was 2x plus 3, right? 2x plus 3 and x minus 1, the quantity squared. Correct?
Yep.
Okay. I graph. Depending who the last one was to use this, maybe the last time you did it was when we're doing regression models, power regression. So you might have to change your window. But, I mean, it wasn't that far off, right? So all I need to do is make sure that those extrema are correct, maybe find 1 or 2 points on the sides so that I don't go too wide. And I'm good. I got my graph. This is how I make a graph more accurately than just, I'm going to plot the integer points I see on my table. Okay? So I will window. No. -66. My ones. -8 to 12. I'm just monkey with my window a little bit, so it's a little bit bigger. And if this is on our graph paper, how about format? Grid lines. There we go. Right. So this is ballpark what you should see on your graph. We already knew that it was going to be at positive and positive infinity. We already knew we were going to be at -3/2, 0, and 1. I just have to label this point is about what, and this point is about what. Okay? And I do that with, second, calculate. Find a minimum. My minimum appears to be somewhere between -2 and 0. Come on, Frank. Do I actually call that -1, -4? Is that round off error, or did it goof? Or is it like not that point? Okay, it's -1, -4. That is a round off error. How do I be sure? Okay, I can check it in my table that it's a value on there. I can plug -1 in and make sure -4 comes out. Okay, so I'll label this one as -1, -4. Second zoom, no, second calculate. Now we go find a maximum. It appears to be somewhere between 0 and 1. Come on, Frank. You can do it. See how that's 0.0001? That tells me this is an actual, that part was probably round off error. What's 0.375 as a fraction?
3/8.
3/8. Okay. So I can call that approximately 3/8, 0.549. Okay. And then I have my zeros marked. We said that was -3/2, 0. We said that was 0, 0. We said that was 1, 0. Okay. This is how you make an accurate graph. In Algebra 2, we did talk about this. We did it a couple of times. But for the most part, you got away with just dump it in calculator, plot points. Maybe you had to put the extrema on there. But now we're specifically talking about that behavior with the zeros. Okay? It's a terminating decimal, so yes. I mean, we had to put approximately anyway because of the y portion of the coordinate, so yeah, that's cool. Oh, when we're doing approximations, how many decimal values am I going out? 3 places. I don't care what the directions ever say, we're going 3 places. The only time I would go against that rule is if we're talking about a specific context like money that goes to the hundredths. Okay? But eighths, thousandths is really when, in my experience, we're still pretty accurate. So, Just A. If we got it good, then I don't see a point in doing more. We'll start with just A. We'll start with just A. No, A. Dad jokes all semester long. 3 more months. Well, yeah, it's March 1st. Or wait, 2nd.
Actually, yes, I did because.
Oh yeah, if you ignore the 0, today is a palindrome.
What?
Palindrome, it's the same forwards as backwards. Sweet.
Yeah, after I said it, it's the first time it's ever happened to me. It's the last time it's ever happened to me.
Are we going into exam?
No, right now we have extended. They didn't vote on it, but the recommendation and what's likely going to happen is they will just move finals back 1 day because you were all supposed to end on Thursday. Now you'll just end on Friday. Where it gets dicey is if we have one more. 3 of the last 4 years, we have had a snow day within 10 calendar days of finals. We 3 of the last 4 years, we have had a snow day within a week of finals. So right now, it's no big deal. Y'all just go 1 more day. You go to that Friday. Big whoop. It's if we have any more, then we got to figure out how they're. Then they got to figure out if they want to come back after Memorial Day or not.
No, I don't think they do.
The problem is by teacher contract days, we have 6 days we got to make up. They might just make us come back for 3 days of finals after Memorial Day because they don't have 6 days worth of crap for us to do.
There's so much stuff that happens like May 29th. Like a lot of the summer events and stuff that
Yep.
starts in that.
If we have any more, I expect that the governor would declare the December storms emergency and forgive those days, though.
Did you put it in your calculator?
3, 9, 27, 54.
Oh my goodness, the color I'm using matches.
Oh, because it's a. Yep.
Wait. Oh.
This song?
Yeah, that's fine.
This is really long.
Whoever just. Actually, that's.
I don't know. We saw one that looked like a sorry game piece 2 weeks ago.
How'd we get the 4?
X minus 4 equal to 0.
Oh, yeah. I just kind of skipped that part.
Yeah, the 0 and the 1/3 being that close to each other, you're gonna have to be careful with how you do your graph. Could you also just extend your x-axis? Could you go by a scale so it fits a little nicer?
Oh, because you have to use it.
I hate everyone.
What's 3 times? We don't have to. 27 times. So if you get 1 Oh.
Cool.
Yeah.
Okay.
I kind of think I look at good times.
Yeah.
Oh, I love how you put out like the little things next to it. Could we do like the absolute minimum? Like how we were taught that.
Oh yeah. I know some of us really, really hate when our graph gets cluttered. So, all right, we know our end behavior, right? Positive to negative. We know our zeros, we know their behavior in between. If you have that general shape of the graph, what was it, 0, like a cubic, yeah. If you, yeah, it's gonna go way up there. Had an appropriate scale, and then right next to it, you just put, maybe put RM, and then off to the side, put your relative minimum. And then over here, put R, oh, I suppose, min. They both start with M. And then did this. If you did them off to the side like that, absolutely. Or label them like points A and B. If you just don't like writing on the graph, you can just put one symbol, one letter, one variable next to it, and then off to the side, go tell me the other stuff. That's big brain. What am I hearing? Like 3,000 something? I like big graphs on a camera.
The minimum is like 0.08. So what's that fraction? No. Yeah.
So, we're all in agreement, it's that general shape. For those who found that relative maximum, how tall be she? There's probably an X before that. 3,000. Okay. I got 10 boxes to work with. I got to go up to 3,200 and change. What I will do, I'm going to make my y-axis here just go by 300s, and I'll just go a little bit off-road. I'll place this at 3 point something. There's 3,000. We'll ballpark it and put that next to it. Okay. What was the minimum? Yay? Nay? Okay. So if you want to write it off to the side like this, and then have your Roman over here, then you can connect some dots and call it good enough. Or no, it was through it. Yeah. Oh, since this has such gigantic numbers, and you have it in your calculator, go over to the table and just let's make sure we don't screw something up in terms of how wide we go. At -1, what do we got? Okay. So I can make a point there. I can ballpark that. What about at -2 though? Way off the map. So this tells me that I need to stay within that boundary of -2 as we come down. Try to make a cubic inflection. And what about as we go to 1, 2, 3? Yeah?
The y for -1 is 640.
Yeah? I'm going by 300s. Just plain old 48? Okay. So I can meh. What about 2, 3? 2 is at 1,000, so 2 is at 300, 5, 900, about meow. Okay, this gives you the general shape of it though. Now I can cubic through here. Okay, it ain't pretty, but I can get the general behaviors of the graph. I have all of my points and information labeled off to the side. Okay, but think about back up to beginning of Algebra 1 when you were freaking out about graphing an absolute value. We've come a long way. Yeah?
You're going over 0.8 and it's just going down, right?
Yeah.
So why is it not?
No, the y value is down. Right a little less than 1 and down. Right a little less than 1 and down.
And that's supposed to be between two zeros.
Yeah. Because it crosses through this one like a line, cubics through that one, goes through that one like a line. Oh yeah, because my scale is going by 300s and you look at that minimum, it's practically on the axis. Sometimes you gotta do that. Ain't gonna be perfect, but it's gonna be better than just I threw it in my table and put 3 points on here and called it good. Okay. It might be 6B, it might be the other one. Yeah, I'd rather do this one because it's uglier. There you go, again. So cross out 6B, do this one instead. Because it's already factored for us. What?
What is this? What do I do with that?
It's a negative x. Set an equal to 0.
Oh, okay. I don't need you. I understand. Okay, we're working together. Okay. Wait. It would be -5. Because you have to set 2 at everything would be -1. Maybe that would be. It's as easy as just takes to go out there. Of course, it's great.
Really stressed on that. Free. Free.
Ew, it's ugly too. What is happening with my calculator? It looks like it's but I
Your generation just has such high standards for beauty.
What? Me? Me? No, I just don't like
Everyone over here calling every graph they see ugly.
Okay, my calculator's coming out eventually. Okay, but that's... I love algebra, but can I go back? I know, like, every time you give me a quiz extra.
No, it is not.
Okay, this was the difference between polynomials that got a bunch of junk in between leading term and constant, and those nice transformation forms we were dealing with the other day.
Oh, what the heck? Why? Anybody know? No, they don't. Okay, well, I just already knew they didn't. Hi.
Eh. That's a negative x. It's going to have an
Oh, what crap, I meant negative. No, don't.
absolute maximum, right? And a relative minimum. Whew. I'm glad we're working, but you're all so busy finding those points that no one caught my goof on the absolute versus relative maximum minimum. Had them swapped. Missed my negative.
How dare you? Oh my gosh, why can't I? Look at how gorgeous that is. There's like one this maximum. I don't even like know where to check them.
Well, one of the maximums is your zero. I mean, if you want to put it, you can. So, before I ever touched a graphing calculator, I can multiply together my leading terms, and I know I'll have a negative something x to the even. So I know I'm going to start down at negative infinity, I'm going to end at negative infinity. I got that much. Whether it's in factored form for me or I factor it, I can find my zeros of negative 5/2, 0, and 3. And because they happen once, twice, and once, I know the behavior at those zeros. So I know the general shape of my graph is going to be bounce off of this one, go through this one, go through that one. I know that's the general shape of it. I also know that the minimum in between 0 and -5/2 is going to be less magnitude than the maximum between 0 and 3, because the distances from the x-axis to the extrema are going to be relatively proportional to the distances between zeros. So that's the general shape of it. Who's got some extrema for me? That maximum, how high does it get? There's probably an x before that. 1.957, 162 what? 0.18. Make up your mind. Okay. How low is that minimum? Plug in Blinky. Get this. If you're way off of that, you might have missed that squared, or you might have missed the negative in front of the x. And just double check. Hey, don't take it personally. I'm just checking.
I'm not. I'm just confused.
Okay. +5, -5. Looks good. Zoom standard.
Maybe it's my old calculator.
Okay. That's just a little bit pixelated, and we'll change our window. We'll go down to like -50, go up to 200, go by 25s, Graphifa. And then you'll use Blinky to find that minimum. Go second, calculate minimum. It appears to be
that's
somewhere
a minimum, not a
between.
maximum. That's what I did. Never mind.
Oh, okay.
Yep.
Found it. All right, and you're all cool with then after you find that, you got to monkey with your scale so that you can fit it to the correct points. Okay? Like that's the general shape of it, but you should be able to change your scale. 10 boxes, I don't know, I'd maybe go by 20s. Right? I mean, whatever fits. If you got to go a little bit off-road, that's okay. I would not recommend going more than like 2 boxes, 2 units off of the map, because after that we start to get a little iffy unless we're just really, really good at our visual. Some people, their spatial orientation, their perception of proportional spaces is really good. Some people aren't. Kind of depends whether you can draw decently or not. So, cool. The other day when we did power regression, for how many of you was that your very first attempt at regression? Okay, a couple of you? When we did the regression stuff on the calculator the other day? Okay. Were you okay with it after writing down the steps? Okay, good, because here comes the spaghetti monster. Okay, too bad. Sammy, I'm just going to tell you, get a different calculator for this. You can do it on that one if you want, but it's going to be nasty. Okay. If you have a black and white screen, you'll be okay, but it ain't going to be pretty. Okay. just because it's going to be harder to see. I'm just telling you, we're about to put 4 different polynomial models on the same graph. It's going to be a spaghetti monster, and if they're all the same color and big blocky pixels, it's going to be hard to tell what's what. Okay? So everyone have your weapon of choice? Okay. Stage 1. Y'all, you did this should have done this in Algebra 2. You are going to compare what the most reasonable model is for your data. They're all found with that regression stuff. So you don't have to do any big brain math. You got to be able to type thing on calculator. The reason that I like keeping this in Algebra 2 and PreCalc is this is a really good example of usage with database entry, of navigating a program. Like, this is cross-curricular. Talk to any of your parents who work in some sort of office environment. Anyone have your family works in insurance or is in the Monument Health System? Okay, ask them what they think about Epic. Epic is the system they use. My wife used it when she worked insurance for years, and I have never heard someone so sweet use so many naughty words. Dear God. I'm just saying, this is good practice for working within a data entry system. Okay? So regardless of what you're going to do, not the math behind it, this is a skill. Okay? Stage 1, if I'm going to create a scatter plot, I want to put my data in, but before we go typing, does anyone remember when we start dealing with years and time, we should probably change things. Okay, you have to identify what your X is going to be and call it years since what? Because if you do 1970, 1980, 1990, you're going to get, what is this? Average personal savings of a person with a y-intercept at the year 0. And the average personal savings of a person in the year 0 was like negative $3 trillion. And that's because in the year 0, there was a lot of really bad stuff and even less human rights than now, although South Dakota's trying. We don't want to say 1970, okay? So instead, what do you want to do? And you get to name it. Do you want to say years since 1970? Do you want to say years since 1900 so you can just use the last few digits? What do you want to do? I mean, no, okay. All right, so right next to this, I want you to state that X is years since 1970, which means I am not putting in 1970, 1980, 1990. I'm instead going to put X is 0, 10, 20, 25, 30, 31, 32, 33, 34, 35. Okay, I'm going to put that into list 1 instead. So stat edit was how we enter our data. List 1, 0, 10, 20, no, it was 25, right? 25, 30, and then 31, 32. Yep, 33, 34, 35.
That's the 33.
I said the emulator, it just does not keep up. Oh, that was a 33, yeah. Okay. Double check your data too. Have someone else look at your list. 9.4, 10, 7. 9.4, 10, 7, 6, 2.3, 1.8, 2.4, 2.1, 2, negative 0.4. And, okay. Double check my data. Emulator and Frank are not a good combination for data entry. Any goofs, or are we good to go?
This works so much faster. Sorry.
Technology improved in 15 years. Okay, then create a scatter plot of the data, determine the type of polynomial that could represent the data. So, how do I get my scatter plot? Second, stat plot. Plot one on, make sure it's the right type. And if you have one of the color calculators, I'm going to tell you that just because, like, when you go to y equals, whatever the colors are here, we're going to use 1, 2, 3, and 4. So for me, I'm going to make my data points purple up here because that's one of the colors I'm not going to use for my polynomials. That way I'll be able to see everything, okay? So whatever you got in Y5 should be green. I would change your data points over to that so that it's easier to differentiate them from the rest of your graph, okay? If you want it to be easier to see your points on your scatter plot once we start putting polynomials through them, I would strongly recommend that for you, you do green. Y'all know the color wheel? Purple is opposite of green. My colors are inverted. I pick up green, it says purple. Okay. Y'all took an art class in middle school, right? The videos, it doesn't have inverted colors, it's regular. That's a lot of back work on OBS, and I don't wanna. Anyway, OBS Live and Streamlabs OBS, they're programs that most streamers use for Twitch, YouTube, whatever. That's what I run on here. So, I'm gonna make a scatter plot. Well, y'all remember the Spring 20 shutdown. A lot of teachers just gave you packets and said, here, do this. I taught myself to stream, and I actually did daily video lessons. I did daily check-ins with kids. Like, we had work sessions through Discord, like, all kinds of stuff. So, but anyway, scatter plot and make it an appropriate color if you decide to. Second stat plot, plot one on. And I will make mine green. Okay. Oh, when I go hit graph right now, I see dot. I don't want dot. Oh, it's gonna, yeah. Finish up, Frank. Let's go. No. So I'm gonna clear that out. Zoom 9 will go directly to my statistics. And now we're gonna start putting in polynomial models. So, remember I showed you how to store. First of all, how do I get line? How do I make a line of best fit through this data? That's a power model. How do I make a line? Linear regression. Okay, stat, especially those of you that have never done this before, we're going to write the models down below that space. Stat, calculate. Ooh, okay. Lori caught it before we could start doing the thing. I'm about to find a bunch of models. Those models are going to either fit well or not. Are your stat diagnostics on? Are you going to get that correlation coefficient? Or has someone reset that calculator since the last time we used it? Okay. So write that next to this example on your paper too. Okay. Lori caught it before I could even start pressing buttons. Yes, turn your correlation coefficients back on. It's under mode, or if you got the old calculators, it's under the catalog.
My calculator. This does too, look.
Okay. So diagnostics are on, stat, calculate, linear regression. All of the newer calculators are going to have this cute little pop-up menu that says, are you sure you want to use list 1 and 2 for your x's and y's? Frequency list, we are not going to use in this class because we're not going to have that much data. You go on and do college stats, you will use that. Store the equation. Does anyone remember how I store it so I don't have to retype it? Not these guys, trace. Okay. Now, I'm going to put my linear model in y1. And then I'll put my quadratic in y2. Cubic in 3, quartic in 4. Oh yeah, we're putting all of them on there. And it's going to make the spaghetti monster. Okay. I calculate. And then over here I will write y1 is negative 0.285x plus 11.236. And then after it, now that Lori caught it, I'm going to say what my correlation coefficient is. Remember, at r squared, not r. R squared says this is a 89.3% fit. You went down to the other linear regression. There's 2 of them. They just swapped the order. Okay, your correlation coefficient should be the same. It should still be the same coefficient of x, the same y-intercept. It's just they're used differently for statistics. We don't care. We don't care, so don't worry about it. Write down your model and write down the correlation coefficient. Yes, ma'am. Same thing that Maddie just said. There's 2 linear regressions. One of them is stat calculate. There's good old mx plus b. You went down to this one. And that's okay. It's just going to give you your a and b backwards. But it's still the...
So I want that one.
Yeah. It's still the same values. It's just swapped. Yeah.
So we'll only do that if you captures me.
Yeah. Okay. Now, if I go to my graph, it's going to show me my scatter plot and it's going to put a line through it. The correlation coefficient said an 89% fit. Look at the graph. If I was just doing a trend line, that's not terrible. But does that fit my data points very well when I look at my graph? Not so much. So I'm going to keep going. Does everyone have the line? Everyone has that written down? Value is not allowed in the... Okay, so you go to. It'll tell you where you goofed. Oh, this is not linear regression. That is logarithmic regression.
Okay, well, this is fun.
And you can't do... Hey, y'all remember, what's commandment 3 of domain? Can't do log of a non-positive. You just tried to do logarithmic regression, and one of our points is at 0. It said domain error because you were trying to do a logarithm of 0. Okay. The calculator isn't dumb, The calculator will say, nah, dude, you can't do that. Okay. All right. She was in here last semester. We did this. Okay. All right. Now, please tell me everyone has that, and we're ready to go on to quadratic. Stat. Calculate. Now go to quadratic. We're going to go through quartic. But this time, be careful. You're going to put your equation into y2. That way, we could see them on the same graph. y2 is about negative 0.0086x squared plus 0.033x plus 9.744. This guy is up to 96.1%. And you don't have to graph this on that graph there. I used to, but it's easier just on a calculator. Okay, time out from it. Look at the graph now, the difference between using a line versus throwing a parabola in there. You highlight the colored box, and you can change those. Okay, so I would like you to also go find the cubic, write the cubic down, put it in y3. Go find the quartic, write the quartic down, put it in y4. Okay? So when you're done, you should have a linear, quadratic, cubic, quartic, spaghetti monster through this data. Stat, calculate, cubic. That's why I said to switch. Yep. Some of these leading coefficients are going to start going to scientific notation. Write 0.000 whatever to that point. I said we're always going to go minimum of 3 places. Sometimes we're going to have to go more to see our data. This would be 0.12375 x cubed minus 0.029x squared plus 0.301x plus 9.424 with a 97.1%. Stat, calculate, quartic. What's the next one? Green, right? Pretty sure it's green. Negative 0.1234174x fourth.
Oh, you're erasing it?
0.16x third. 0.5 squared plus 0.498x plus 9.385. That was. Okay. Let me know when you're there. And you've got linear, quadratic, cubic, quartic. You got the spaghetti monster, all three. See why I said having that color screen might be beneficial here. Okay, it is not required, but boy does it help. Okay, bear with me here. We're getting to the how and the why. Or that was the how, now the why. Everyone there? Or almost there?
Why is it doing that?
What? It's saying it's ax to the fourth, bx to the third, cx to the second, dx plus e. Those are the coefficients.
Oh.
Screen's only so wide. They give it to you like that instead. Okay. We get all the models. We have Spaghetti Monster. All of them look to do kind of the same thing, right? But they have different fits. Why did it start at 89, then to 96, then to 97, then to still practically 97? Okay. Notice how that leading coefficient kept getting smaller. It's kind of like the law of diminishing returns. It's like if you've stayed up until 3 a.m. studying for a test, stop that. You're not doing any good. It's not going to affect it any more than just going to bed and getting sleep. Okay? Yes, this might be a better fit, but now we have to look at the context of the problem. What was X?
Year since 1970.
Okay, so the year, time. What was Y? How much of your income you will save. All of these appear to be headed the same direction. If I'm going to, I want you to write this part, interpolate. Interpolate. Interpolate is in my data. If it's inside my data set, then I'm just going to use whatever's got the best fit. I'll pick the quartic. Because the quartic fits the data that is there the best. Where things get dicey is when we go further. Remember, this window only goes out 38 years past 1970. This goes to 2008. What if I wanted to know how much you all are going to be saving towards retirement? What if I went out to, say, from 0 to 100, out to the year 2070? 50 years from now, a whole lot of you are potentially looking at retirement. Okay? Now watch what the graph does. Frank's going to take a while. I switched my window out to 100 so we can extrapolate. Extrapolate, interpolate is inside my data, extrapolate is outside my data. If I extrapolate past my data set, some of these models don't make much sense. Okay, waiting for Frank to stop there for a second. Say you had this problem on a test and I asked, what would you expect your percent of your income is saved in the year 2023? How many years after 1970 is that? 53. So I'll trace, I'll go to the line, 53 years out. Says everyone's a little bit in debt. Yeah, that's about right. I go to the quadratic. Everyone's a lot of bit in debt. You just keep arrowing down and it goes between the different functions. But then I go to the cubic. The cubic is a little bit more in line with my data. I go to that quartic that fit it perfectly. I'm pretty sure when they found this data, they weren't expecting a global catastrophe, but 20% in debt is actually about right. You have to think about what is more reasonable in the context of the problem. I would not use the quartic because the quartic doesn't really line up with my data if I go past my data set. It doesn't make sense. I would actually use the cubic to answer my questions. Yes. My white one, your black one. Yes. Okay. We will start with one of these tomorrow. I'm going to include probably just 2 or 3 of the graphing problems for homework. We're going to start by doing this again tomorrow.
As a daily check.
No, just more practice with it.
Sounds spectacular. Look at my mom's in the back. My mother already fixed it. Well, that is